Okay, as the previous section that we've seen, the derivative of ln or natural log of x is equivalent to 1 over x. Now, I took my time to derive that because this is a very important function, or at least a very important derivative. Why? Because here we see that if the derivative of this gives us this. Now, talking about antiderivatives or integration, it's pretty much the opposite. In other words, integration of 1 over x, which is the antiderivative, just gives us what we had right here, ln of x. So, those are two functions that we've derived already. Their integral and the derivative. Now, talking about transcendental functions, another important derivative that we should know is the derivative of e to the x. Now, this I've actually proved in a different video, and I'll post it right there. But pretty much the derivative of e to the x is very surprising because the derivative of e to the x is actually e to the x. Okay, but once we know this, let's actually go away from e. What about things that are not e? For example, if I had instead of e, let's say a random variable a to the x, what's the derivative of that? Well, we can use a simple trick using the natural log derivative that we've seen here. So let's actually write y equals a to the x. We're going to use implicit differentiation. Now, if we take the logs of both sides, in other words, ln of y equals ln of ax, a to the x of course. Now, what happens is we're actually exploiting a property of logs. Because there's a power here, we can actually bring it into the coefficient. X ln a equals ln y. Okay, we're almost done, don't worry. Now you can just take the derivative. The derivative of ln y, as we've seen here, is just 1 over x. In this case, it will be the derivative of y over y. So, we write dy dx, because of course it's respect to x, over y equals, in this case, this is a constant. So it's just ln a. And now we want to isolate what dy dx is. So we're going to move the y over here. We're left with dy dx equals ln a and times whatever y was. Y in this case was a to the x. That's just a to the x. So, the derivative of a to the x is just ln of a to the x. In other words, the natural log of whatever that base was times the original exponent. So, that is the first step that we've done, and now let's actually continue to the log form. Here we've seen how the natural log of x, its derivative is just 1 over x. Let's actually look into other things. For example, here we have log. Instead of base e, we're going to have base a of x. Okay? So how would we find that? Well, we have to exploit more log properties. Now we're going to use change of base of our log toolkit, and this gives us, we're going to change it back to ln because it's very convenient. Ln x over ln a. Now this constant ln a can just be written right here. It didn't do anything. It's just more convenient. And now once we have it in this form, it's fairly easy to take the derivative. It's just the derivative of this, and it's constant. Constant doesn't change anything because it's being multiplied, and the derivative of ln x is just 1 over x. So, the derivative of log ax, where a is just any other constant other than e, it's just 1 over ln a times 1 over x. Okay, good so far. Now, let's actually think about its integrals. So, we've done the derivative of a natural log. We've done the derivative of the exponential, of course, of the e. Then we've done the derivatives of the counterparts that do not include e. Let's actually include the integral now. We found that the derivative of a to the x is simply ln a to the x, right? Well, what about its integral? What is the integral of ln a? Oh, my bad. What is the integral of ax? So, how would we find this? Well, there seems to be there's a very tight connection between the derivative of a to the x equals ln a to the x. You see how this always remains constant? Well, let's actually try to take the derivative again of a to the x. Remember when we did the ln of both sides? Bring down the power. take the derivative of both sides, dy dx equals just ln a times y. In this case, it's just dy dx equals ln a to the x, right? Well, in other words, if we take the antiderivative of this, it'll cancel out. In other words, the antiderivative of ln a to the x is simply a to the x, because the integral would take us back to where we were if we took the derivative. Well, now we're almost done. Ln a is a constant, which can be removed from an integral. So that's ln a integral a to the x equals a to the x. Okay, let's actually isolate this integral of a to the x, because that's what we're looking for, right? So we divide by ln a in both sides. And ta-da, what do you get? Integral of a to the x is simply a to the x divided by ln a. And we've just found that using simple differentiation. No need to memorize, just think about it. So hopefully that helped you get the derivatives and some integrals of the basic transcendental functions. And until next time, please subscribe.